Children, the lesson is physical and chemical changes. Each and every substance in this world has various qualities. Certain qualities relate to the color of the object, density, shape, size, volume. These are all the physical variables. They are termed as the physical qualities of a material, physical attributes. As against that, you have the chemical attributes, the chemistry of that substance. How does it react with other substances? What is it composed of? How are the atoms? How do they look like? What is its ability to combine with other elements and compounds? The reactions it puts forth when it comes in contact with other substances, all these pertain to the chemical aspect. So two aspects. Whenever you want to describe a material or a substance, you have to describe it from two angles. One is the physical angle, the other is the chemical angle. Let's see now. Physical changes. Physical properties of a substance are those characteristics of a substance that describe its physical nature. How does it look like? What is its density? What is its texture? Now all these together, they explain the physical attributes of that substance, or the changes it undergoes are physical changes. Example, color, density, how thick the material is, how close the molecules are, that is density. Shape, is it a solid, liquid or a gas? How does it fill up space? These come under density, and shape, size and volume. How much space does it occupy? Physical change is a change which occurs when there is an alteration in the physical properties of a substance. Physical property, I take a sheet of paper. I tear it into pieces. I tear it with my fingers into a number of pieces. Now this change, what I described now, or what one may do with a sheet of paper, tearing it into pieces, is a physical change. Chemically, the paper has not undergone any change. To begin with, it was a full sheet. Once you tore, it has got converted into a number of pieces now. It is in pieces. But chemically speaking, it's one and the same. There is no difference. Physical quality has changed. Earlier it was one entire sheet, now it is in pieces. So physical change is a change which occurs when there is an alteration in the physical properties of a substance. I boil water. Water turns into steam. But steam is also water. Water has transformed into the gaseous state from the liquid state. But it is water. You condense that steam, you get back water. You cool it further to a below 0 degree temperature, then it turns into ice. Though it is ice, it is still water. Physically, it has changed its form and shape. its shape might have changed, density might have changed, volume, that too might have changed as water turns into and ice into water. Volume may change, but it is still water. Now this kind of change from solid to liquid to gas, or backwards from gaseous state to the liquid state to the solid state, or the tearing of paper, these are examples for physical change. Physical change. The physical change does not result in the formation of any new substance. These are the various attributes, features. No new substance is formed. You may ask, steam, is it not a new substance? But you can come back to water from steam. It's a temporary changeover. It can come back. Chemically, it has not undergone any change. So, there is alteration in the physical properties of the substance, but it has not resulted in the formation of any new substance. It's not a new substance, it's the same old substance, that's water. So such changes are known as physical changes. Next, here you have a number of examples for physical changes. See, now this is gold. How do you say it's gold? It's a picture ultimately, but this shining, the luster it has makes us believe that it is gold, because gold is shiny. This is shiny. It's a physical attribute. That physical attribute gives us the clue that it must be gold, and you have to find it out. Whatever it be, gold is shiny and it's a physical feature. Here you have a drum here. No, it's a metallic plate. A big metallic plate we have, and you hit it. It's a gong, a huge gong, and you hit it with a small stick. This metal gives a beautiful sound. It vibrates, you get the sound, because the metal is sonorous. What is sonorous? It produces a beautiful sound, a beautiful vibrating sound. So here you can hear and know the attribute of the metal. It is sonorous. It can produce sonorous sound. Feel. You can feel physical properties. How? Here you have rubber, and you can bend the rubber. You can bend it. You can feel that bending, and leave it, it gets back into its original shape. So you feel it. Rubber bends. Look here, gold shines. Metal is sonorous, and here rubber bends. Here you have a ceramic pot. A ceramic pot, it is hard. You can't bend it. It is not soft. You can't press it. It is hard. A ceramic pot is hard. What you call is china clay. China clay. For touch, when you touch it, you feel it, that it's hard. So from china clay you have cups. Tea cups you have. Tea cups. You drink tea in that. Acid. You have acid in this conical flask. If you keep it on the table with the acid filled into it, you get the smell where you are standing. You get that acidic smell. Acidic smell. That smell is sour. It's irritating. The smell is irritating. You don't enjoy it, because acids are sour, and that smell, as it reaches your nose, you feel that irritation. Acid smells sour. Smell. Here measure your body temperature. It's a physical attribute. If you have a thermometer, you can find out your body temperature. No changes come in, only the temperature has risen a bit. That you can measure with the help of a thermometer. So, with the thermometer you can say whether a person is running fever or not. So you measure temperature. See, all these are physical properties. Physical properties of things, we can see them, we can hear them, we can feel, we can touch, again you feel, you can smell, and you can measure. They are all physical properties of things. Now, look here, physical changes. What we saw now were physical properties, attributes. Physical changes now. What physical changes do we find in nature? Do we find around us? Look here, you have a can, soft drink can. You suck the soft drink in the can. Now the can is empty. Before you throw it into the dustbin, maybe you crush it. You crush the can and throw. When you crush, the shape of the can undergoes a change. It's beautiful. It was cylindrical, but once you have crushed it, it has lost its shape. But has the chemistry changed? No. The physical quality, physical shape, the shape of the can has changed. Maybe the size has got reduced. So crushing a can, it is a physical change. If you can even bring it back into its original shape. You will have to strive a bit, struggle a bit. Ice, you have ice cube. You keep the ice cube in a plate and just watch. The normal temperature of the room will make it melt. Ice starts melting. Ice, which is a solid, slowly gets converted into water, a liquid. Now this changeover from the solid state to the liquid state, it's a physical change. If you want the water to be brought back into the solid form, the ice, you can keep it in an ice cubicle in the refrigerator and you can get it done. It's vice versa. The changes are reversible. Changes are reversible. Boiling water. You boil water. It starts vaporizing. If you have a lid, under the lid you see the water drops getting collected. The steam starts getting condensed on the under surface of the lid with which you have covered the vessel. So, from water into steam, from steam back into water, vice versa. It goes both ways. It's a physical change. The substance itself has not undergone any change. Substance is there, form is changed. Mixing sand with water. Take water in a vessel, put a handful of sand into it. Now, sand has got mixed. It's temporary. If you leave it aside, all the sand particles will start going down and they get collected at the bottom. And water will be there above sand. They get separated. You can filter or you can decant. Separate water from sand. It's possible. You can get back water from the mixture of sand and water. Mixing sand with water. It's a physical change. Here, breaking glass. You have a glass. Drop it. Or hit it with a hammer. The glass breaks. It's a physical change. Glass might have broken, But glass is there still. Glass is glass, it is in pieces. Earlier it was intact in one piece, now it is in a number of shredded pieces. It is a physical change. Glass has retained all its properties, except that the shape has changed. It is in pieces. Look here, dissolving sugar in water, just like that of sand in water. You have a glass of water, you pour a spoonful of sugar into it. Water will turn sweet. It's a mixture of water and sugar. Water and sugar. You can get back the sugar if you want. If you heat it, all the water in the vessel will slowly get evaporated and sugar will remain there back in the glass. You can get back sugar. It's a physical change. Shredding paper. With a scissor, you go on cutting paper into thin slices. Now, it's a physical change. Physical change. It's not a chemical change. Here, chopping wood. You have a wooden log. You chop it into small pieces. It's a physical change. Here, mixing green and red marbles. You have marbles. Some green marbles, some red marbles. You put them together, mix them. It's a physical change. You can separate them once again if you want. The change is not permanent. Physical changes are all temporary changes. The last one here, sublimation of dry ice. Dry ice. It sublimes. It changes its shape. Changes its form. It changes its form. It's a physical change. It's not permanent. We feel as if it's changing, but no change has taken place. Exact whatever has happened, it's a physical change. So all these are physical changes. We see lots of physical changes around us. Next. Chemical changes. Let's see what chemical changes are and you will be able to compare the two. The chemical properties of a substance are those characteristics of a substance that describe its chemical nature. The chemistry of the substance changes. The very chemical makeup of that substance will undergo a change. Then you call it as a chemical change. When a chemical change takes place, you cannot get it retraced. You cannot get back the original materials because it is a chemical change. The very makeup of the material will undergo a change, a chemical change. Let's see. Example, toxicity of a substance or how a substance reacts with other substances. Toxicity. Toxic nature. Certain substances are toxic in nature. If you consume, they will definitely bring about a chemical change in the chemistry of the body. We may fall sick over a few days or we may even die. See, to what extent things happen. Toxicity of a substance or how a substance reacts with other substances. A chemical change is any change in the chemical properties of substance. The chemical properties undergo a change. The best example I can tell you is to take a sheet of paper and hold it on fire. It catches fire. It burns and you have ash there. It turns into ash. From that ash, can you get back the sheet of paper that you had burned? Definitely not possible. It has undergone a change. It has undergone a chemical change. You burn agarbattis. It gives smell, it burns. Once it burns, from the ashes you cannot get the agarbatti back. It's a chemical change. The food goes into our stomach. There it gets digested. You have different enzymes working on that. Hydrochloric acid that's secreted by the inner layer of the stomach. The food undergoes change. The food undergoes such drastic changes, chemical changes, that you cannot get back whatever food you had consumed. It's not possible. Whenever a substance undergoes a chemical change, a new substance is formed. So, in all chemical changes, you get a new substance getting produced. The original substance will absolutely, it will undergo a total change and give rise to a new substance. That's chemical change. You can't get back the original material. Next. Now what is it? A few examples we will see. I gave you one or two examples just now. Rusting of iron. Very good example. You have the window rods, iron rods in the window. Those rods have got rusted. In the rainy season, you had not painted those iron rods. Iron comes in contact with water vapor and air, surrounding air, and it undergoes rusting. Iron oxide gets formed. Iron loses its shine. The very quality of iron goes on deteriorating day by day. Powdery substance comes out. Now that is rusting of iron. To prevent rusting, you have to paint the iron rods. Iron rods have to be kept painted. You have to cut off iron from coming in contact with air and water in the atmosphere. Thereby, you can see that iron remains without getting rusted, without undergoing any chemical change. Rusting of iron occurs when iron gets in contact with moisture in the atmosphere. Second one, when a magnesium ribbon is burnt, magnesium metal comes in the form of ribbons. When you burn it, it radiates white light and converts into ashes. It burns bright white. Magnesium ribbon, if you hold it in the flame, it catches fire and it will burn with dazzling light, and magnesium combines with oxygen in the air to give magnesium oxide. Magnesium oxide. It's a chemical change. You don't have magnesium existing there. It has already got converted into magnesium oxide. It's a chemical change. It has undergone a total change. Its molecular structure has undergone a change now. Formation of medicines. Many different kinds of medicines are made in pharmaceutical companies. You get them in the form of syrups or ointments. Now all these would have undergone the chemical change. You cannot once again get back the materials what you had used to prepare them. Chemical reactions take place and you have whatever you wanted as medicine. Formation of medicines. Extracting of iron from iron ore. Iron ore we get in the mines. From that iron ore we get iron. We extract iron from iron ore. It's a chemical change. We have to add many supplements and get it burnt in furnaces. You have to get it burnt in furnaces. Okay. Formation of plastic. Plastic is a big chemical change from petrochemicals. From waste in the petrochemicals, you get plastic produced. It's a chemical change. We use plastic for various necessities. You can't get back the original substances now because it has undergone chemical change. You see a few examples here. Toxicity. Certain toxic substances as you take in, they kill you. They kill the cells in your body. They are toxic in nature. They are poisonous. Oxidation states. Oxidation, different states of oxidation. Magnesium gets oxidized when it burns. Sulfur gets oxidized. It becomes sulfur dioxide. Now this stage of oxidation, they are all chemical stages, different chemical stages from one state to the other. You can't retrace. You cannot get the original materials. Heat of combustion. When you heat something, when you get something burnt, that's what you call as combustion. The heat of combustion, whatever happens there, it's all a big change. A big change. Materials undergo change. These changes are not retraceable. You cannot get back. Chemical stability. Certain chemical items in the chemistry laboratory, they maintain their chemistry. They maintain their stability. They don't undergo change because molecular setting is there. They have a definite makeup, molecular makeup. That molecular makeup cannot be broken. It remains stable in the lab, in the containers in which we keep there. So chemical stability, it's a big chemical feature. It won't undergo any change as such. Flammability, a flame burns, it's a chemical change. A flame burns, burning of a flame is a chemical change. Oxygen enables the flame to burn. And there is a combination of items, combination of materials, and flame burns. You cannot get back the original materials. It is a chemical change. Here, coordination number. See, this is a particular molecule. It has a particular setup. Here, maybe it is NH3, let's say, one nitrogen atom and 3 hydrogen atoms, let's say. It is NH3 then. It is a molecular structure, a molecular formula. They have absolute binding with one another. It has its own molecular formula. Accordingly, the molecules are composed, they are formed. So they have a chemical stability here, unless another chemical reaction starts, wherein they succumb and combine with another material or dissociate, whatever it be. Then reactivity. When a reaction takes place, when an explosion is there, or when two chemicals react, you have new substances getting formed. It's a chemical reaction. Possible chemical bonds. See, possible chemical bonds. Two molecules are coming together to form another chemical substance. Now, such a situation is a chemical change. You cannot break it easily. Then you have enthalpy of formation. Enthalpy of formation. Whenever a substance gets formed, it has a set amount of heat encompassed in it. Enthalpy. That enthalpy is well set. So these are the various attributes or chemical properties of different substances. I think you have made out the difference between physical changes and chemical changes. Okay, we move to the next frame. See here, a cracker is exploding. What kind of change is it? Yes, you are right. It's a chemical change. It's a chemical change. It undergoes such a change that you cannot trace it back. Chemical reactions take place here. You have bright light coming out, sparkles coming out. You enjoy it. So, it's a pyrotechnic show. Then here you have burning of phosphorus. White phosphorus, you burn it. You have a big flame here, very bright flame. Phosphorus trioxide, phosphorus pentoxide, they get formed. Then here you have magnesium burning. we spoke of magnesium ribbon burning in the last train. Here you can see a bright light it gives. A small piece of magnesium, you hold it in the fire with a handle. It catches fire and burns with a very bright light. You call it as dazzling light. With a dazzling light, it burns. Magnesium burning. A chemical change is always accompanied by any one or all of the following. Let us see the attributes of a chemical change now. Not necessarily that all these should be there. Even if 2 or 3 of the attributes are there, you can call it a chemical change. Not necessarily that all these 6 should be there to call a change as a chemical change. Let's see, radiation or absorption of heat. When a chemical change takes place, either it absorbs heat or it gives out heat. It gives out heat or absorbs heat. Then production of sound. See, when this particular chemical change took place, you had the sound. Here you will have sound. Here you will have hissing sound. Sound will be there. When the chemical change takes place, there will be sound. Change in the color of the substance. The substance color may not remain the same, it undergoes a change. A new substance is getting formed, so the color changes. Change in the smell of the substance. After the chemical change, whatever substance you get, it will have a different smell from those which had taken part in the reaction. Formation of a gas gets formed, may get formed, a gas may get evolved, emerge out. Then formation of a solid as residue. When chemical change has taken place, ultimately there will be some residue, something left off. It will not clear off completely, there will be some residue. Okay, next. Now here you change in property, let us see. Radiation or absorption of heat. I told either heat is given out or heat is taken in, consumed. Burning of a substance such as coal, wood or candle. In all these cases, it results in the production of heat. Heat is produced and hence it is a chemical change. It is a chemical change. Similarly, melting of ice results in absorption of heat and therefore it is a chemical change. In case ice is melting and it absorbs heat from all the surroundings, from that angle you can consider it as a chemical change. From that angle, because it absorbs heat and undergoes a change. Production of sound, bursting of fireworks is a chemical change. All pyrotechnics show. It results in production of sound, heat, radiation as well as gas. When the fireworks are there or a pyrotechnic show is there or crackers are burnt, you will have sound there, you will have heat there, you will have radiation there, you will have gas getting produced. So they are chemical changes. Change in the color of the substance. We are taking examples for each of the attributes. Raw fruits. You have brought a raw mango fruit and you have kept it for ripening. And vegetables, when cut and left in open air, start acquiring brown color due to a chemical change. You cut an apple and the cut apple you keep it on the table for 15 minutes. You will find the color of the cut apple undergoing an absolute change. It starts becoming brown. This oxidation takes place. It's a chemical change. You get astonished as to what is it that makes the color of the apple undergo a change. So raw fruits and vegetables, when cut and left in open air, start acquiring brown color due to a chemical change. Similarly, rusting of iron results in change of color of iron to reddish brown. Rods undergoing rusting will definitely have a change of color. reddish brown color will be there. The shine of the original iron rod won't be there. So it's a chemical change. Next. Formation of gas. For each of these we are taking examples now. When antacids are mixed in water, antacids, they are put into water. Bubbles are formed indicating the production of a gas, and therefore it's a chemical change. Some of these tablets, when they are put into water, it will result into a juice, a juicy solution. You enjoy it. And when you put that juice tablet into water, effervescence will be there. And you get a ready juice produced, a ready juice. Now, that is a case of chemical change. Change in the smell of the substance. When food gets spoiled, you have kept some food for the next breakfast. In the morning you see it is smelling. You forgot to keep it in the refrigerator. You feel sorry. The food has undergone change. Food has got spoiled. Because the food has got spoiled, it is giving out a particular nasty smell which tells you that food is not good for consumption. For when food gets spoiled, it produces foul smell due to chemical change in food. Rotten eggs often produce a bad odor due to production of sulfur. Rotten eggs. It gives out sulfurous smell, odor. It's a very irritating smell. Usually when you go near these omelette shops, you get a smell, a bad smell you get. That's mainly because the shells that are thrown out everywhere, the shells will be undergoing chemical reaction and the smell is getting produced, and maybe even the contents inside the egg. Formation of solids. Two liquids combine with each other and form a solid called precipitate. There will be precipitation sometimes from the atmosphere. Rain is precipitation. Rain is precipitation. For example, shells of animals are precipitants formed by chemical changes. Chemical changes get brought about as the egg is getting formed in the ovary of the mother and the shell gets formed. Here, different materials come together and shell gets formed. Shell takes the shape. It becomes hard and it gives protection to the young one inside. Now that is a chemical change. Next. Here you can see iron rusting. Iron, when it gets rusted, it is a case of chemical change. Wood, you burn wood. Wood gets burned down, it's a chemical change. Metabolism. We take in food. Nutrients in the food are absorbed by the blood. It goes to different parts of the body. There it aids in the metabolism of the body. Metabolism. Metabolism is growth part. Addition will be there. Your body gets the needed energy. Food, when it gets burned, as it comes in contact with oxygen, energy gets produced. Cooking an egg is a chemical change. When you cook an egg, it undergoes tremendous changes. Then baking a cake. When you prepare a dosa or a cake, what happens there is a chemical change. There are a lot of chemical changes taking place. And you have the cake. Electroplating. An old vessel is there, an old vessel. You want to get it electroplated. You can say something like a copper vessel or brass vessel or some metallic vessel, you want to get it electroplated. You can. Electroplating, you take it to the one who does the job and there will be a thin layer of another substance over that. Electroplating is a chemical change. Then rotting banana. Banana is getting rotted. Now that's a chemical change. You cannot get back the old banana which is there. vinegar and baking soda mixture. You put vinegar and baking soda with one another, mix them, and you have the chemical change. It's a chemical change. Then fireworks. We have discussed it. All fireworks are chemical changes. Then these chemical batteries. Batteries give us energy. Batteries give us electricity. Now the kind of reaction that goes on inside the battery wherein electricity gets produced, it is a case of chemical change. Next, rusting of iron. You will see it little detailed. When iron comes in contact with oxygen and water, iron, oxygen and water. If oxygen and water are not available, iron will not undergo rust. So there will be more rusting in the rainy season. If the iron remains exposed to the rain and air. Air you can't help. But it should not keep getting drenched again and again. Otherwise you have to paint it. It reacts and forms a red colored substance over it. It is called rust. See, the rust gets formed. 4Fe, Fe means iron. Fe is the molecular formula of iron. Plus O2, 3O2, oxygen. This oxygen. Plus 2H2O, water. These are the three items, chemicals required for the reaction. Iron plus oxygen plus water gives the three react and you have rust. Rust is 2Fe2O3H2O. It is a complex item, a complicated item. That is formation of rust. You have water here, you have iron here, oxygen in the air, all these three combine, there will be a chemical change and rust gets formed. Rust gets formed. The iron becomes useless later. If you allow it to rust continuously, the iron chain you have been using, that will get broken somewhere because it becomes weak. It gets cut. Next, how to prevent it? Yes, iron gets rusted. How to prevent it? Because iron is an ingredient we use for many of the day-to-day necessities. By applying paint, just now we said, apply paint. Not as the rust is there, before it starts rusting you have to paint it. Even if it is rusted, you have to remove the rust with sandpaper and then you have to paint it. Applying paint on iron objects so that they cannot come in contact with oxygen and moisture in the environment. How is it possible, you may ask? It's very simple. Iron, when it comes in contact with air and moisture, it rusts. Now put a screen there such that iron won't come in contact with oxygen and water. What can you do? A layer of paint. You paint it. You have a swing in your garden. You have hung the swing with the help of iron chains. Before the rainy season starts, see that the chains are properly painted after removing all the rust there. And the 4 months of the rainy season, you can be safe. Your iron chains holding that swing will not rust because the paint doesn't allow water and air to come in contact with iron. Galvanization of iron. This is another way. Means applying a layer of zinc or chromium metals on it. On iron, instead of painting, you get it galvanized. You have a layer of zinc or you have a layer of chromium. That is also a screen that prevents iron from coming in contact with water and air. So galvanizing iron is also a procedure. Crystallization. What is crystallization? Let's see. It is a process of obtaining crystals of pure substance from its solution. For example, we can obtain the crystals of copper sulfate by boiling copper sulfate solution. Copper sulfate, you make it into a solution, make it well saturated, well saturated. What does it mean? Dissolve as much copper sulfate as possible in that glass of water. Dissolve, dissolve. Heat it. As you heat, the capability to take up more copper sulfate, that will be on the increase. And once the saturation level is reached, that means the solution cannot take any more of copper sulfate, you allow it to cool down. As it cools down, it throws copper sulfate out of the solution. Because temperature has come down, it cannot hold that much of copper sulfate now, it throws it out. When it throws it out, copper sulfate comes out in the form of crystals. Beautiful crystals. Let's see that. Next. See here. You have a glass full of glass. We have taken water. Here you have copper sulfate solution in this. A bowl. In order to see that the temperature rise is uniform, we have used the vessel with water here, boiling water. Water will be boiling because you have the burner here. The burner here, water is boiling. From this boiling water, the copper sulfate solution here slowly catches up heat. The temperature increases. And you add copper sulfate to it. The burner, slowly the solution will start cooling down. As it cools down, in the china dish or bowl here, you see copper sulfate crystals getting formed. Because temperature is coming down, as the temperature of the copper sulfate solution comes down, it cannot hold that much of copper sulfate which it was holding when the solution was saturated, and they will fall out in the form of small crystals. So crystallization of copper sulfate. I understand you have learned all the differences between physical changes and chemical changes. Especially when you study a substance, you should know its physical properties and also all its chemical properties. Thank you.